let me introduce you to returnation and what a Willgol is. The second returnation of 2 is a Willgol. Let's work it out. We'll just do an example, it's easy. So we're going to work out this. So we do the first step. 2 to the power of 2 equals 4. Second step, 4 to the power of 4 equals 256. So all we do is we use 2, we make it the base, the power and the limit. So it's 2 to the power of 2, and I do 2 steps because it's the limit. That's it. Easy. So now I know the second returnation of 2 equals the first returnation of 256. So I can write second here as that n is ordinal. Good. So now we know exactly what we need to do next. So the second returnation of 2, second, step 1, it's 256, which is our base, our power, and it's also going to be our limit, so we've got 256 steps to go. So 256 to the power of 256 equals 3.23 times 10 to the power of 616. Right, I'm going to abbreviate that to make this go a bit quicker. We'll go 3e616, which is 3 times 10 to the 616 to the power of 3e616 equals 10 to the power of 10 to the power of 618. So now we're into power towers. Step 3. Remember, we've got 256 steps to go. So now we have 10 to the power of 10 to the power of 618 to the power of itself. Now, I'm going to start estimating and using tricks because these numbers just get way too big. Let me show you. If we go with 10 to the power of 10, that equals 10 billion. 10 to the 10 to the power of itself equals 10 to the 10 to the 11. Then I have to go 10 to the 10 to the 11 to the power of itself. 10 to the 10 to the 11 equals 10 to the 10 to the 10 to the 11. So this is where we just start estimating. For the sake of simplicity, I'm just going to make that a 0, make that a 0, 0, 0. Now notice what happens here. I have 1, 2, 3 tens, and then I get 1, 2, 3, 4 tens. So if I did this again with a power tower of 5 tens to the power of itself, now I know I'm going to have 1, 2, 3, 4, 5, a total of 6 tens. And there's an easy way to write this out. It's using tetration. It will be 10 to the 6, or the 6th tetration of 10. Normally you have a power over here. This is tetrated. That 6 means I have a total number of 6 tens. So if we use that same trick here and just pretend that's a 10, yes, I know this is not a good way to do mathematics, but you'll see why we're doing it shortly. I'd have 3 10s, now I've got 4 10s. So in the fourth step, now I know how many 10s I'll have. I would have 5, so it would be the 5th tetration of 10. In step 5, it would be the 6th tetration. Now, to make this correct, let's go approximately. So we've got steps 6, 7, 8, 9, all the way down to 256. So on step 256, well, now I know it's going to be 10 to the 10 to the 10. How many 10s am I going to have? I'm going to have a power tower of 257 10s. So this is approximately equal to the 257th tetration of 10. But we know this is too small, so it's less than the second returnation of 2. Why is it less than? Well, look what we did. We skipped out this. We skipped out this. All of these things are going to make it way, way bigger. This is already a massive number. Remember, it's 10 to the power of 10 to the power of 10. And when you work this out, you start from the top down. 10 to the 10 is already 10 billion. We've only just started. You've got 257 steps to go. Either way, the second returnation of 2 equals 1 Willgol. And even if you wanted to write that out, you wouldn't have space in the universe. See where we started here? 256 to the 256. It's a number with over 600 digits. A Willgol is going to look like this, but it's going to fill the universe, it's going to fill the multiverse. It is a massive number. But now you have an idea of how to work out a Willgol and how big it is.